Hello and welcome to another one of these ADD videos. Today we're going to be going over the concept of evaluating this inequality. So anytime we have a polynomial with a power of x greater than 1, polynomial with a power of x greater than 1, here we have an x to the 6th, an x to the 4th, both of these are greater than 1, and we have one of these inequalities, whether it's less than or equal to, greater than or equal to, or greater than. If one of these symbols is present with a power of x greater than 1, you have to do sign analysis. Again, by now you should be familiar with the steps. Find the cut points, plot on the number line, pick an open dot or closed dot. In this case, we're going to have a closed dot. Pick a test point on either side of these cut points that you found when you set it equal to 0, and then find out whether it's positive or negative. We don't care about the actual value. All right? Let's see it in action. All right, so the first thing you're going to do is you're going to find your cut points, and you're going to go off to the side, set it equal to 0, and you should notice that there's an x to the 4th that's common to both of these, so you're going to factor out the greatest common factor. Now, when we do so, to figure out what's left, you're going to take what you had originally and divide it by what you're factoring it out. So x to the 6th divided by x to the 4th gives you x squared. X to the 4th divided by x to the 4th gives you negative 9. Then you should recognize that this is a difference of two perfect squares. So once you recognize that, this has to be a minus, doesn't work if it's a plus. Then you take the square root of x squared, write it down twice, take the square root of 9, write it down twice, you get this here. And then you put a plus sign in one and a minus sign in the other. Don't forget to bring down the x to the 4th because it is part of the problem. Then set them individually equal to 0 because they're multiplied equal to 0. Then solve for x. First one, you're going to take the 4th root of both sides. 4th root is 0, 0. Here you add the root of both sides, subtract the root of both sides. You can get these cut points. So then you plot these cut points on the number line. Notice they have closed dots here because of the equal sign present under the inequality. It's greater than or equal to, so they get closed dots and brackets when you do the interval notation. And here in this scenario, we're going to need 4 test points, one on either side of each critical point. So I chose negative 10, negative 1, 1, and 10. You could have chosen 4, negative 2, 2, and 5. As long as they're in between these points, that's what matters. So what we're going to do is we're going to plug in these test points into this factored form is easiest. And I don't need to worry about x to the 4th because it's always going to be positive. Any even exponent will ensure whatever's being plugged in is going to be positive. So when I plug in a negative 10 into this, I'm going to get a negative 10 minus 3 is negative. Negative 10 plus 3 is positive. Negative times a negative is a positive. Plug in a negative 1. Negative 1 minus 3 is negative. Negative 1 plus 3 is positive. Negative times a positive gives me a negative. Hence these negative signs. Then plug in a 1. 1 minus 3 is negative. 1 plus 3 is positive. Negative times a positive gives me a negative. That's why I have these negative signs. Then plug in a 10. 10 minus 3 is positive. 10 plus 3 is positive. Two positive numbers being multiplied together give me a plus, 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 plus. Any number I plug in here, whether it's 5 or 10 or 100, should give me positive. Any number in between here should give me negative. Same thing here and here. All right? So what was the question asking me? The question was asking me, if you remember, where it's greater than or equal to 0, which would be indicated by the plus sign. So we get that from the very beginning. So the plus signs are occurring everything to the left of negative 3, everything to the right of 3. But that's not it. Don't forget that it said or equal to 0. So we have to include this closed dot here. It's not going to be a range of numbers. So we're not going to use the square brackets or the parentheses. We have to use the fancy brackets for 0, the solution set brackets, to indicate that 0 is part of the solution. It does equal 0 there. All right, so you read this like a sentence left to right, and because of this arrow going infinitely in that direction, we have to start at negative infinity, always a parentheses with any infinite value, whether positive or negative. And it remains positive until we get to negative 3. And we include negative 3 as a closed dot. Indicates a bracket being used here. Now we have to include that 0. We're not going to include anything before it or after it, so we have to use these special solution set brackets, the fancy brackets, as some people like to call them, or the squiggly brackets I've also heard. At that point, we then jump to 3, include the 3 because of the closed dot, and everything to the right of 3, which would be all the way up to infinity. All right? And again, infinite gets a parentheses. Again, quick recap, 6th power inequality, that's going to be your sign analysis clue. We find our cut points by setting it equal to 0. When we do so, we notice x to the 4th, pull it out, difference of 2 squares, plus or minus, same thing. And then they're multiplied and equal to 0, so individually equal to 0, you get these cut points. You got a test on either side of these cut points. These are the test points I used. You could have had different ones as long as they're in between and on either side. And then when you plug in, you get plus, minus, plus, and it asks for greater than or equal to 0, so that's this region, including this. Jump to here, only that point, jump to here from there on. When you do so, you should get this interval notation. I hope I've explained this. You can see some of them are a little tricky, but not too bad if you keep your wits about you. The worst thing here is some people trip themselves up on factoring. If you don't have that foundational block down, you're going to see it throughout your math classes. Might as well nail it down now. All right? So practice, practice, practice. As always, thanks for watching. Have a great day.